Continuing on with our 2.1 lesson, there is one more thing that we need to talk about, and it's special cases. So when this happens, the variable is going to cancel out, which means the variable disappears. Sometimes that's okay, and sometimes it's not. So let's look at both cases. This ends up being a no solution case, and you may or may not be able to guess what happens when the variable cancels out, but let's find out. So I need to get rid of the parentheses first and foremost. So I get 2 times x minus 2 times 3, so that'd be 6, and 2x minus 4 over here. I need variables on one side, numbers on the other. So let's just say we wanted to move our variables to the left side. A positive 2x, and the inverse would be a minus 2x. So I'm subtracting 2x, it's going to zero out or cancel over here, and I'm left with a negative 6. I'm left with a minus 4, and then I have a positive 2x and a negative 2x. Oh, those canceled also. So there's no more x. X cancels. So look at what you have on both sides of the equal sign. You have a negative 4 equals a negative 6. Is that true or false? Well, it's definitely false. So when you get a false statement, we call this no solution. There's no x value that you could plug in here that you'd get the same number on both sides of the equal sign. No x satisfies this equation. It's always going to come out unequal. Let's look at infinitely many. So again, you could probably guess what happens in this situation. But we're going to distribute, and we get 2x minus 2 times 6, which will be 12. Drop down everything else, and distribute over here. I get 5 times x and 5 times negative 2, so negative 10. Let's combine some like terms. So I have x terms over here, 2 and negative 12. When I do that, I get 5x and then negative 10. I kind of already see it, but I want to go a little bit further. I notice that look at both sides of the equal sign, they're the same. But let's go one step more. And again, let's move this x value over here by subtracting to cancel out. So I have negative 10. Oh my goodness, those are going to cancel too. And I get 10 equals 10. So is that true? Yes. So we call this infinitely many solutions. And because it's infinitely many, that means we could plug in any number for x, literally any number, and we're always going to get both sides of the equal sign to be true. Okay, any number I could plug in and it satisfies the equation. So be careful for these types of special cases, a no solution and an infinitely many solution.